You have integrated Claude into your workflow, but have you truly secured it? Most developers make critical mistakes that expose sensitive data. Today, I will show you the exact architecture patterns used by top companies to keep their AI implementations safe. Your AI is already leaking secrets. Let's lock it down for good. You are probably using environment variables right now. Good. But what you are missing is that rotation schedule, and that's your vulnerability. The key insight is that static secrets, even hidden ones, become toxic over time. You must enforce mandatory, automated rotation. This isn't just a best practice, it is the non-negotiable discipline that separates a secure system from one waiting to be breached. Your API key is a powerful, unrestricted key. Does it really need that much power? Implement scoping to cut its permissions down to only what's essential for the task. This isn't about limitation, it is about precision. What you are doing is building a failsafe, ensuring that even if exposed, the key's damage is strictly contained. A quiet key is not a safe key. Anomalous traffic is your silent alarm. Imagine being alerted the moment usage spikes from a new geography or a novel endpoint. That early warning isn't just data, it's your window to respond before a leak escalates. This layer of vigilance turns passive security into an active, intelligent defense system. But here's the urgent truth. A single, shared key is a ticking time bomb. If it's compromised, your entire operation is exposed. Segmenting your keys limits the blast radius. A breach in development will not touch production. It's not just organization, it's a critical containment strategy that isolates risk and protects your core systems. Every AI integration you have built is vulnerable to this hidden data leak. This isn't a feature request. It is a non-negotiable command. Craft your system prompt to issue a direct, permanent order: do not retain, store, or log any user data from this session. This explicit prohibition creates a contractual boundary the AI must obey, locking your data inside the conversation where it belongs. Consider this a sanitization protocol before data reaches the AI. You define a strict filter: names, account numbers, any unique identifiers, and strip them out. This transforms raw user input into anonymous, structured data. The AI processes intent and context, not personal details, creating a powerful yet privacy-first interaction from the very first keystroke. Think of this as building a digital safe room for your conversation. You are not just filtering words, you are architecting the entire interaction space. The AI only operates within the secure context you provide. This means it physically cannot access or speculate about anything outside those predefined intellectual walls, fundamentally containing its reasoning. Now, here's the critical pivot everyone overlooks. An audit trail isn't a boring log file, it is your definitive truth. Each recorded pair becomes an immutable record. This transforms security from being reactive to proactive. You are not just tracking prompts, you are building an incontrovertible history that documents intent, response, and accountability at every single step. What if your AI assistant just leaked your secrets? But once your data goes into an AI, what stops it from leaking back out? The key insight is that without clear architectural guardrails, data can recirculate in unintended ways. What this means is you must enforce a strict, one-way flow. This isolates your proprietary information, preventing any chance of it looping back into the model's training or responses. The pattern clearly indicates that raw data must never reach the AI directly. Here's what's really happening. You strip out all personally identifiable information at your system's edge. The key insight is you create an irreversible layer of abstraction. What this means is Claude only ever works with sanitized data, permanently severing the link to your original source. But message chunking isn't about convenience, it's your final defense. Without it, even anonymized data, once reassembled, could expose patterns you worked to hide. The key insight is you are not just managing length, you are actively deconstructing context itself. This permanently destroys any narrative thread an AI could use to infer sensitive information, making your abstraction truly complete. Think of your logging system as a museum guard who knows exactly which artifacts to protect. It allows visitors to appreciate the exhibit's flow while ensuring priceless pieces remain in the vault. The crucial practice is designing logs that capture operational health and errors, but automatically redact any payload data, API keys, or user identifiers before a single byte is written. Is your AI assistant secretly a backdoor for data theft? Think of a junior team member accidentally triggering thousands of requests, draining your budget. Your data's protected, but your wallet is exposed. Throttling by user role stops this. Limit free-tier users to safe volumes, while granting trusted roles higher ceilings. This isn't just about control, it is about predictable, sustainable operations, ensuring your integration remains alive and financially viable. Budget alerts act as your financial circuit breaker. They notify you the moment usage deviates from expected patterns, allowing for immediate intervention. This transforms cost from a passive monthly surprise into an active, manageable parameter. The key insight is that true control comes from visibility. You cannot protect what you do not measure. But dashboards alone are reactive. The crucial step is implementing tiered rate limits. This isn't just about controlling spend, it is a core security layer. By defining strict request caps per user or API key, you actively prevent abuse and contain potential damage, ensuring system stability for everyone. Here's what's really happening. You are shifting from monitoring costs to proactively enforcing them. And when those limits are hit, your system must degrade gracefully. The key insight is that a failed API call should never break your user's experience. What this means is designing intelligent fallbacks like cached responses or simplified logic that keep core functions running, transforming a potential outage into a mere reduction in capability. Your AI's private replies might be your biggest data breach. Think of these tests as staging a security drill. The key insight is that you are not testing if your prompts work, but how they fail under pressure. A successful test reveals where your guardrails might crumble, exposing the exact paths an attacker would take to extract or manipulate your data. Let's borrow a trick from the movie industry. They do not just check the stunt's design, they film it from every possible camera angle. The principle is the same. Your testing needs to explore the digital blind spots. This ensures no matter the angle of attack, your sanitization holds, leaving attackers with nothing to find. But model drift is the real unseen threat. While you are guarding the front door, the intelligence you depend on can subtly change behind you. This isn't about catching a single bad response. It is about detecting when the model's core behavior and risk profile starts to silently evolve away from your security baseline. Your baseline is a living document. Regular audits must interrogate whether your controls still match the model's evolving capabilities. You are looking for the gradual creep. Did a new reasoning pattern inadvertently create a data leakage path? Security isn't static, so your validation cannot be either. This ongoing pressure test is your true defense. Secure Claude architecture requires layered defenses from API keys to prompt design. Proper data flow management prevents accidental exposure of sensitive information. Continuous monitoring and testing are essential for maintaining AI security. Review your current Claude implementation against these architecture patterns this week.